lecture on Newton's laws of motion. Our today's subtopic will be law of conservation of linear momentum. पहले हमने देखा in discussing the laws कि linear momentum जिसको हम define करते हैं as a product of mass and velocity of a body. तो ये linear momentum P से हम denote करेंगे. It is product of mass and velocity. ये असल में क्या करता है कि it is representative of quantity of motion in a system. A body which is in motion, उसमें amount of motion को अगर हम measure करने की कोशिश करें तो उसका index ये quantity है which we call as its linear momentum, उसकी mass और velocity का product. न्यूटन्स second law हमें ये कहता है कि अगर एक force किसी system पर act करे then this force causes a change in linear momentum with respect to time, and that we express like this, that rate of change of linear momentum is directly proportional to force. वहाँ पर जो constant of proportionality है that is equal to 1, so I write F equal to d over dt of P. So linear momentum का जो time derivative है that is equal to the force. Now law of conservation of linear momentum takes a very important place in physics, क्योंकि जब भी हम किसी phenomenon की बात करें, whether we have a phenomenon at subatomic level, atomic level, macroscopic world, or in the world beyond, that means astronomical world, so there is always conservation of amount of motion. We can neither create amount of motion nor destroy amount of motion, provided system एक isolated system हो. Isolated system का मतलब यह है कि अगर कोई भी फोर्स सिस्टम पर एक्ट नहीं करता है then its linear momentum remains constant. So we have a statement for law of conservation of linear momentum. It states that the total linear momentum of a system remains constant if the system is isolated. Isolated means no external force acting on the system. हमारे आसपास कुछ फोर्सेस जो हमेशा प्रिवेल करते रहते हैं, जैसे फ्रिक्शन हुआ, एयर रेजिस्टेंस हुआ, आपको इन फोर्सेस को भी बाहर निकालना है. You have to expel these forces. So we have alternately a definition like this, that the law of conservation of linear momentum, which states that the linear momentum of a system will remain constant if no external force acts on the system. We start with a very simple system. हमारा सिस्टम मान लेते हैं एक सिंगल पार्टिकल है, उस सिंगल पार्टिकल का मास है m और उसकी वेलोसिटी है v. तो मैं न्यूटन के सेकंड लॉ को यूज करके मैं ऐसे कह सकता हूँ that if this force which is F external becomes equal to 0, then d over dt of P becomes equal to 0. Later on we will see कि यहाँ पर जरूरी नहीं कि सिस्टम में सिर्फ एक्सटर्नल फोर्स ही एग्जिस्ट करे. There is every possibility कि सिस्टम में कुछ ऐसी इंटरेक्शंस हों जिनमें एक इंटरनल फोर्स भी एग्जिस्ट कर रहा है. We'll take up that case later. तो अभी के लिए एक सिंगल पार्टिकल जिस पर कोई भी एक्सटर्नल फोर्स एक्ट नहीं कर रहा है, एक्सटर्नल फोर्स इक्वल टू 0, which means as per this equation d over dt of P is equal to 0. So this leads us to the result. The result is if derivative of a quantity with respect to time is equal to 0, then this quantity must be a constant with respect to time. And this constant linear momentum could have a form like this. If I say m into v is a constant, some constant k, then we can say कि अगर एक पार्टिकल जिसका मास फिक्स्ड है, अगर हम उस पार्टिकल की बात करें, its velocity must remain constant. That way मैं constant को डिवाइड कर रहा हूँ m से, provided mass remains constant, we have v equal to a constant. Now what it means कि v is equal to constant. जो velocity एक वेक्टर है, इसमें दो चीजें हैं. There is a speed जो इसका magnitude है, and there is a direction. This implies कि जब हम velocity को constant रखने की बात करते हैं, the body should not have any change in its speed and there should be no change in the direction of motion. Now taking this example further, we can think of a system now consisting of more than one particle. More than one particle. ये एक system है. इस system में एक particle है of mass m1 with velocity v1 और एक मास m2 है with velocity v2. I have put a box around it. That means this is the system, और जो बाकी का surroundings है, the rest of the universe is its surroundings. तो हमारी consideration सिर्फ इसके अंदर क्या हो रहा है उस पर होगा. No force is coming from outside. That means जो बाहर से कोई force आने वाला हो, that is not there. That is zero. Now in that situation, what I say, I calculate now from the same Newton's second law. जो Newton's second law है, from Newton's second law, where I say F is equal to d over dt of P, I calculate the total linear momentum of this system as a product. The product will be m1 v1 plus m2 v2. And as such, I substitute it here. I say F is equal to d over dt of m1 v1 plus m2 v2. So I have taken the total linear momentum of the system, which is algebraic sum of the individual momentum. ये इसका जो momentum है, this is momentum p1, that is linear momentum of this body first, and this is p2, linear momentum of second body. अब जब आप ये m1 और m2 को constants मान के चलते हो, that is mass does not change, so we have m1 into d over dt of v1 plus m2 into d over dt of v2. Now this is change of velocity of first body with respect to time. This is change of velocity of second body with respect to time. So I can say this is m1 a1 plus m2 a2. और a1 और a2 जो है, they are vectors. So if I now say that this F which is equal to 0, so ये force body 1 पर act कर रहा है, ये body 2 पर act कर रहा है, तो when I say that this outside force, the external force, this is external force, is equal to 0, so I have F external equal to 0, which means 0 is equal to m1 a1, or I call this as F1 plus F2 equal to 0, and this becomes F1 equal to minus F2. What does this mean? This means that now the system where we have two particles moving, what should be a possibility कि अगर हम कहते हैं कि net external force 0 है, फिर जो force F1 और F2 है, उनके बीच में ये relation है that these two forces must be equal and opposite to each other. And this equal and opposite nature of the forces becomes significant. About these forces, F1 and F2, we have to be clear कि अगर external force 0 है, फिर ये कौन से forces हैं? The only possibility is कि अगर external force 0 है, these must be some internal forces within the system. दोनों. And this equation indicates कि अगर ये दो internal forces हैं, एक body 2 पर act कर रहा है, m2 पर act कर रहा है, एक m1 पर act कर रहा है, तो इनका nature ऐसा होना चाहिए that they must be equal in magnitude but opposite in direction. This reminds us of Newton's third law, जहाँ हम कहते हैं कि action and reaction must be equal and opposite to each other. So this opens a possibility कि अगर external force 0 है, हम internal forces को नहीं रोक सकते. We don't stop internal forces from action. Let them act. Let there be a collision between the masses. Let them interchange some momentum with each other. Let there be internal forces, but those internal forces must be equal and opposite. That is what we demand here, and that is what nature has already in it as Newton's third law. अब इस situation को हम और ज़्यादा elaborate करेंगे in terms of two particles traveling together along a single line, one-dimensional case where they collide together. Let's go to that situation. The process of collision between two particles of mass m1 and m2 moving along a straight line. Straight line का मतलब है that this is a one-dimensional case. So let's say ये हमारे पास है mass m2. I call it as a body B. ये हमारे पास mass m1. I call it as body A. Let this is moving initially with a velocity u1 and this is moving with a velocity u2. Let the velocity u1 be greater than u2, so that ये जो particle है, it comes from behind and collides with m2. Collision would mean कि for a short while these two masses, ये है m1, ये है m2, they meet together and they exchange some force. What is that force? There is a force acting on m1 due to m2, and there is a force acting on m2 due to m1. These two forces we will talk later as the forces of interaction, but they are internal forces. System के बाहर से कोई external force नहीं आ रहा है. Even we have eliminated friction. इसमें friction भी present नहीं है. When they emerge after collision, so this is mass m1 traveling with a velocity v1, and this is mass m2 traveling with a velocity v2. So this is our situation. This is m2 traveling with v2. तो ये बन गया before collision. So this is before. This is at time of collision, and this is after the collision is over. We bring some mathematical calculation into this. So you agree with me कि अगर हम system को लें, which consists of now two particles m1 and m2, what is total linear momentum? So we have total linear momentum of system, momentum before collision. Before collision. So it will be algebraic sum of the two linear momenta of the m1 u1. You understand, एक body A का linear momentum है और m2 u2 is the linear momentum of body 2 or body B. तो हमने इनको add कर लिया. These here are along the same straight line, जिसकी हम advantage उठा सकते हैं, that we may take these two as scalars, u1 and u2, because direction same है. Scalar algebra will be at work. Not necessary कि we will require parallelogram law or triangle law. Now total linear momentum of the system, momentum after collision. After collision. So that you will agree is after collision the velocities are v1 and v2. So we have m1 v1 plus m2 v2. हमारा ऑब्जेक्टिव सेट हो गया इस प्रोसेस में. We want to prove कि even in presence of internal forces जो इन particles के बीच में act करेंगे, the total linear momentum before collision and after collision will remain same because there is no external force acting on the system. अब अगर एक body एक ही तरफ आप देखोगे, there is a change in its linear momentum. Its final linear momentum is m1 v1. Initial was m1 u1. So we can think of change in linear momentum of A, body A. So that is equal to m1 v1 minus m1 u1. So that way m1 u1 is its initial momentum, m1 v1 is the final. तो हमने इनको subtract कर लिया. Similarly, we can talk about change in linear momentum of body B. So it will be equal to m2 v2 minus m2 u2. So again, m2 v2 is its final linear momentum, m2 u2 is its initial linear momentum. So the difference of these two gives us change in its linear momentum over a period of time. Now this change in linear momentum, as per Newton's second law is concerned, has to be attributed to some action of force. So think of this change in linear momentum taking place during time delta t. Which is that time delta t? That time delta t is the time during which collision lasts. तो मान लेते हैं कि ये जो collision है, this collision between the two masses, it lasted for some time. That time interval was delta t, a short time interval, or this time interval delta t can be now utilized for using the Newton's second law. So I can say force which acted on A is the first ball. So the force which acted on A and this force must have come from B only, because there is no external force including friction. So force on A due to B, this I denote as FAB. So since it's a force acting on A due to the source B, there is change in linear momentum, of A divided by time. Now I have already calculated the change in linear momentum of A, which is equal to m1 v1 minus m1 u1. So it is m1 v1 minus m1 u1 divided by delta t. Delta t is the time during which this change took place. I have also the force on B due to A. So this is equal to FBA. So as per the same relation, change in linear momentum of B divided by time taken. So this time taken in that case is also equal to delta t. I have m2 v2. So this is m2 v2 minus m2 u2 divided by delta t. तो अभी तक हमने न्यूटन के सेकंड लॉ को यूज किया, that an external force, which is probably a force which is acting on A due to B, a force acting on B due to A. So in दो forces को हमने the relation Newton's second law, that it is the rate of change of linear momentum, उससे हमने calculate कर दिया. Now what I say is that there is a restriction on the existence of these two internal forces, these two FAB and FBA and FBA are not coming from outside, are internal forces. Since they are internal forces, a relation which must be true between them as far as Newton's third law is that they must be equal and opposite to each other. So I denote that equation like this, that they are magnitude wise equal but direction wise opposite. Now I substitute for FAB, I substitute m1 v1 minus m1 u1 divided by delta t. For FBA I substitute, ये minus sign मैंने यहाँ लिख दिया, so this is FBA, that is m2 v2 minus m2 u2 divided by delta t. The moment I make this equation, delta t and delta t gets cancelled, so I can rearrange the terms. यहाँ मैं ऐसा कर सकता हूँ कि m1 v1 इसके साथ मैं ये टर्म जो है जब माइनस साइन से मल्टीप्लाई हो जाएगी, so this will be minus, so minus m1 u1 is equal to, ये माइनस हो जाएगा माइनस m2 v2 और ये हो जाएगा प्लस m2 u2. So minus into minus is plus. Now I shift this m1 u1 to the right hand side, I shift m2 v2 to the left hand side. So I finally have m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2. तो यहाँ आप देखिए जो राइट हैंड साइड है, दिस इज टोटल लीनियर मोमेंटम ऑफ द सिस्टम बिफोर कोलिजन, m1 u1 plus m2 u2, और जो इसका लेफ्ट हैंड साइड है m1 v1 plus m2 v2, it is total linear momentum of the system after the collision. So this is total linear momentum of the system after collision. What we have proved in this? हमने ये प्रूव किया कि these two bodies have interacted. They have changed their velocities, although their mass remained constant. They have interacted, they have collided with each other. इन्होंने आपस में motion exchange किया, जिसको हम कह सकते हैं इन्होंने आपस में linear momentum exchange किया. But even though that thing happened, what remained constant during this process was the total linear momentum of the system. This is what we call as the law of conservation of linear momentum. We have now a number of examples where we see law of conservation of linear momentum at work. A very common day-to-day experience. ये बड़ा simple एक activity आप देख सकते हो, आपने देखा भी होगा, which requires to be now understood in terms of physics involved in this. तो मेरे पास एक balloon है. I fill this balloon with air. Now this filled balloon has a state of rest right now. That means there is a mass of air inside it, there is mass of the balloon, and the total linear momentum of this system is equal to 0, because मैं इस सिस्टम को देखता हूँ कि अगर मैं इस कमरे में, इस लेबोरेटरी में इसको रखूँ तो मैंने एक पोजीशन पर इसको रखा हुआ. Now this balloon, if we allow it to split apart means let's expel air out of it, इसे बाहर निकाल लेते हैं air, that means a mass will come out. जब mass इसमें से बाहर आएगा, अगर वो नीचे की डायरेक्शन में जाता है तो वो एक लीनियर मोमेंटम अचीव करता है. अगर बैलून का जो ये प्लास्टिक है, रबर है, ये ऊपर की तरफ जाता है, ये भी लीनियर मोमेंटम एक्वायर करता है. अगर एयर नीचे की तरफ जाता है और बैलून भी नीचे की तरफ जाता है, there will be some net linear momentum which the system will have. Whereas we said कि initial linear momentum, if it was equal to 0, the final must be also equal to 0. तो उसके लिए एक ही पॉसिबिलिटी है, वो पॉसिबिलिटी ये है कि अगर बैलून खुद अपवर्ड जाता है, the air expelled should go downwards, या अगर air expelled downwards जाता है, the balloon must be pushed upwards. तो sometimes अगर आप प्योर ग्रेविटी पर सोचें कि रबर, एयर दोनों तो masses हैं, they must fall downwards, but no, here another dominant thing comes out. That dominant thing is कि there is a force which is going to be generated, because to keep the linear momentum equal to 0, which it is right now, there has to be कि अगर बाहर की तरफ air expel होता है नीचे की तरफ, the balloon must go up. Recoil of gun एक और common example है. तो recoil of gun will make a principle like this कि अगर हमारे पास एक bullet है which is inside a gun और इस बुलेट को हमने फायर आउट किया. दिस बुलेट goes forward with a mass m moving with a velocity v outwards, और ये जो गन है it is now capital M. The mass without bullet of gun is capital M, and let's say it has a velocity capital V. Before the firing took place, the bullet plus gun system, they were at rest, and since they were at rest, the linear momentum before, that means the initial linear momentum of the system was equal to 0. But once the bullet is fired out, there is a linear momentum in this direction, and that is mv. And if I say this is the linear momentum in the forward direction, what should happen here? इसने भी एक अपना linear momentum achieve किया है, and that linear momentum is capital M capital V. ये गन का है, ये बुलेट का है. Since this is the final momentum, so I call it as PF. F stands for final momentum. Or applying law of conservation of linear momentum, we find that the total linear momentum of this system must remain conserved. जिसका मतलब ये होगा जो उसका linear momentum initially था, that must be equal to the final linear momentum. So I equate these two. When I equate, I have mv plus capital M capital V. That is final linear momentum must be equal to initial was 0. तो अगर ये एक velocity है forward, ये भी एक velocity होगी, I can obtain an equation. The equation would be that I have capital M capital V equal to minus M small v, ये small v है. Then I have capital V equal to minus M divided by capital M into small v. Now this is a forward direction. ये पॉजिटिव डायरेक्शन है फॉरवर्ड. अगर इसका नेगेटिव हम लें, दैट विल बी बैकवर्ड डायरेक्शन. इसका मतलब यह है इस इक्वेशन का कि द वेलोसिटी विच गन हैज एक्वायर्ड, जिसको हम रिकॉइल वेलोसिटी कह सकते हैं इस केस में, दैट रिकॉइल वेलोसिटी इज अ वेलोसिटी विच इज अपोजिट टू द डायरेक्शन ऑफ वेलोसिटी ऑफ द बुलेट एंड इज गिवन बाय द रेशियो ऑफ मास ऑफ बुलेट डिवाइडेड बाय द मास ऑफ गन. एंड दैट वे यू विल रियलाइज कि क्योंकि ये रेशियो जो small m divided by capital M है, it will be much less than 1. So maybe gun does not go back with the same velocity as that of bullet, but it will have a finite velocity in the backward direction, and that is its recoil velocity. इसी argument को हम apply कर सकते हैं और इसी equation को हम apply कर सकते हैं on determining कि what happens in case of emission of an alpha particle from a nucleus. जो न्यूक्लियस है, अगर ये किसी एटम का न्यूक्लियस है, से द एटम इज सम एटम X with atomic number Z and its mass number is A, यहाँ से एक fragment बाहर निकल गया which is an alpha particle. So this alpha particle is a helium nucleus He24, और you will see कि जो हमारे पास एक residual nucleus रह गया, that residual nucleus will be A-4 Z-2, और ये जो residual nucleus है, it will have a recoil velocity. That means when alpha particle is emitted in the forward direction, जो ये residual nucleus है, it will get a backward velocity or a backward jerk as the gun got. So that is the recoil in case of a nuclear system, where law of conservation of linear momentum is applicable exactly in the same manner as applicable here. Think of a man standing on a boat, and boat is on the river, it's on the water. When man jumps forward from the boat gets a recoil backward. Again, the same mechanism at work. And we can use almost similar equations for all these cases. The concept is same. Then, as we saw, in case of a balloon, a rocket is a very huge mass, a system, which is to be propelled into the space. तो वहाँ पर हम क्या करते हैं? We burn some gas inside, burn some substance inside the rocket, और उससे जो गैस बनती है, उस गैस को exhaust करते हैं outwards, so that once the gas is exhausted downwards at a huge mass rate, which could be sometimes tons per second, thousands of kilograms per second, जब वो नीचे की तरफ expel होता है, the rocket is pulled upwards. Again, the law of conservation of linear momentum at work. And these types of all examples, they illustrate, as we stated earlier, that there is always a possibility that we can shift motion from one system to another system. There is a possibility that we can transfer motion from one system to another system. But we can neither create motion nor destroy motion. What is indicating the amount of motion in the system is the linear momentum of the system. The moment I say that linear momentum is constant, that way, अगर external force act नहीं कर रहा है, उस external force की absence में इस motion को system के अंदर बढ़ाना या घटाना, even though the internal forces may be acting, वो possible नहीं है. In one of the previous lectures, we made an example that what should happen if a man is standing in a bucket, he is not able to pull himself up. Same thing. Internal forces are at work within the system, but until and unless an external force comes and is acting on the system, it cannot probably move. And for the last part of this, ये मान लीजिए एक bomb है, और this bomb is exploded. ये bomb जब explode हुआ, इसके दो fragments हो गए. So this is fragment number 1, ये बन गया fragment number 2. If I tell you कि fragment number 1 moves forward, इस बॉम्ब का मास था कैपिटल M, और इस फ्रेगमेंट नंबर 1 ने m/2 का मास लिया और आगे की तरफ बढ़ा विद ए वेलोसिटी, जो इसकी वेलोसिटी थी, दैट वेलोसिटी वाज 20 मीटर पर सेकंड. यू कैन अप्लाई योर माइंड हियर कि व्हाट शुड बी द मोशन ऑफ दिस मास 2. वेरी सिंपल, बिकॉज m/2 ये लेके चला गया, ऑब्वियसली जो फ्रेगमेंट 2 है, इट विल आल्सो टेक अवे m/2, एंड आई कैन से that this m/2 fragment will have to move in a direction which is opposite to this. Reason, because initially the linear momentum of the bomb was 0, it was at rest. तो अगर ये चला गया m/2 into 20 लेके, जो इसकी velocity है वो भी होनी चाहिए m/2 into 20. This is conservation of linear momentum. So I am multiplying the mass of this fragment with the velocity, so that अगर ये बन गया linear momentum in the forward direction, there must be equal and opposite momentum in the opposite direction, so that sum total of these two linear momenta remains 0, as it had the initial linear momentum equal to 0. So far we have talked about two bodies. That means अगर दो fragments हैं, दो particles हैं. If there was a third fragment now, अगर हम इस bomb को 3 हिस्सों में divide करें, then you may have to use the same concept, लेकिन be careful that when you are finding resultant of linear momenta, you are adding vectors, not scalars. For that case, you might have to bring in the law of addition of vectors, that is either triangle law or parallelogram law, to find out कि अगर दो linear momenta, अगर 3 linear momenta है, एक इस direction में है, एक इस direction में है, एक इस direction में है, तो उनको कैसे add करना है. You have to adopt the parallelogram law of addition, या कहते हैं triangle law of addition. So that we will take up during the solving of problems on this, but principle remains the same. Law of conservation of linear momentum is applicable to any number of particles, be it n particles, 3, 2, 1, whatever.